Welcome to this screencast where we will learn how to write a formal proof. In a typical course introducing the writing of mathematical proofs, there are usually three main points. First, we seek to learn and understand certain mathematical concepts. Second, we learn how to prove things about those concepts. And third, we learn how to write about the mathematics. It is important as we progress through this course not to forget the importance of really good writing. We want to make progress in developing our analytical skills, our critical reasoning skills, our problem-solving skills, and our communication skills. If we are not able to communicate effectively, then our mathematical effectiveness is diminished. The analytical, reasoning, and problem-solving skills are used to convince ourselves that we have solved a problem. The communication skills are used to convince everyone else that we have solved a problem. When presented with a problem, the first step that we want to take is to explore it. When given a specific statement, the first thing to do is determine if that statement is actually true or false. We don't want to waste time trying to prove that something is true if in fact it is false, and the exploration of the problem will help us determine that. The easiest way to explore a problem is to try some examples. Is there evidence that the statement could be true? Is there evidence that it could be false? The second step is to prepare the proof and do some mathematics. Once we are fairly confident that a statement is true or false, we must prove our claim. Before we can write a formal proof, we need to do all of the thinking, all of the working, and all of the planning, and do the mathematics that is required to prove the problem. An outline or some notes should be completed prior to writing the formal proof so that we can focus on quality writing when the time comes and not be focusing on the mathematical steps. We want to know the mathematical steps before we ever start writing down a formal proof. The third step is to actually begin the proof. This is where we will begin doing the formal writing. We first want to provide a carefully worded version of the statement that we are trying to prove. Below this carefully worded statement, we actually want to start the proof by writing the word proof. And we want to do this in italics or in boldface, something that sets it apart from the text around it. Immediately following the word proof, we first want to state any assumptions that are to be made for this particular problem. Sometimes it is useful to restate what you are trying to prove, but this is a stylistic choice that you can make for yourself. It is certainly not a requirement. As we will learn, there are many different types of proof techniques that we will make use of, and it is important to point out to the reader which proof technique you will be using. Here's a very general example. Suppose we are given some theorem that says something about a real number x. So x is a real number, and some assumptions are made about this number. And then some conclusion can be made about this number. To begin proving this, we would start with the word proof, followed by a list of the assumptions. In this poorly defined and general example, we are simply saying that x is a real number, and we're making some collection of other assumptions, and these should be stated in the first sentence of your proof. And then, if you chose to make a restatement of what you're trying to prove, your second sentence might be something like, we want to show whatever it is you are wanting to show about x. And we will do this using, in this particular case, a proof by induction. Once you have a nice formal introduction to what you're about to do, now it's time to do the nitty-gritty mathematics. Remember that we have really done all of the work proving the statement way back in step 2. Now we just have to put it into a formal written presentation. To do this, of course, we want to use our notes and use the outline and use all of the stuff that we did way back in step 2. And while the stuff we wrote down in step 2 may have been scratch work or arithmetic or a simple algebra or just a collection of thoughts, we now want to formalize this and write it in complete sentences. As we write out these complete sentences, of course, we will be making use of mathematical symbols. For example, when doing basic arithmetic and working with equations. But remember that mathematical symbols are words. Make sure that the words you use around them make sense. It is important to remember that throughout your writing, you want to always be guiding the reader. Especially in a long proof, guide the reader as you work through it. Tell them why you are doing what you are doing. If your proof has multiple parts, let the reader know when you are finishing one part and beginning the next part. We want to justify each step along the way. If you are using some previously learned facts, such as a theorem or a property, Give the reader some idea of what it is. We can use phrases such as, by the mean value theorem we know that, or this is true by commutativity of addition. Statements like this can be helpful to the reader and can help guide them through the proof. Although it is perfectly reasonable to say, by the definition of a rational number, we know such and such and such and such, it's not really necessary to say by definition. If it's obvious that you're just using the definition, you don't have to say that you are. As you're working your way through the proof, think about your audience. Is more justification necessary or is less justification necessary? For the purposes of writing proofs within this course, assume that your reader is another student taking the course and learning the material with you. Perhaps they are at the same level of understanding as you are, or at a slightly lower level than you. Provide enough detail that you can guide any of your classmates through the argument of your proof. Make sure you think about what is and what is not relevant. If something is not relevant, you do not want to include it in your proof. It's also a good idea to check all of the assumptions within your introductory statement and make sure that you've used them all somewhere within your proof. If you have not done so, it could mean that something is wrong with your proof. On the other hand, it could also mean that the assumption was not actually necessary. Also, never use what you are trying to prove within the proof. For example, if we are trying to prove that two things are equal, we don't write the equation and manipulate it using algebra until both sides match. If you write the equation or the statement you're trying to prove and then work with that, you are assuming that it is true, not proving that it is true, and it's important that we never do that. The fifth and final step is to actually finish the proof. Once you have all of the math content that you need, we are now ready to wrap things up. Tell the reader when you are done. We usually end with some sentence like, therefore we have shown blah blah blah, where blah 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 is the statement that we are actually trying to prove. We also want to end with some form of a QED. QED are just the initials for a Latin phrase which means that which was to be demonstrated. Usually we literally use the words QED or some type of a square at the end of the proof. Of course, we could use whatever symbol we like, as long as we're consistently using it throughout the document. Let's go back to our very general example that we were looking at earlier. Just a repeat of our introduction that we had before. We have the word proof, we have an introductory statement of the assumptions, and we say what technique we will be using as we prove it. Of course, then we have some math content that should be there. And then after that math content, we have a conclusionary sentence such as, therefore, we have proven that conclusion that we were wanting to make about X. And then we end with a nice little QED box here at the end. Finally, we want to look at some basic writing standards that we use within the realm of mathematics. It is our convention as mathematicians that we use the pronouns we and our and us. We do not want to assume a superior position compared to the reader, and the use of the collective we places the writer on the same level as the reader. The main point is to emphasize that the writer and the reader are doing the mathematics together. In general, we would like to use italics for variables and other types of math content. Again, this is just for when we're typing out the mathematics. If we're handwriting it, this is not necessary. Also, we will usually want to display important statements. These things should be centered on the page and well aligned. If you're doing algebraic manipulation and you have a string of equalities, you should have those equal signs all well aligned. If the left side of the equation does not change, then it probably should not be repeated over and over again. Although the use of some mathematical symbols is okay, we try to avoid excessive use of these symbols. In formal writing, we avoid using symbols for the quantifiers and the connectives. Any use of these is considered informal and can be used within your scratch work, but once we are writing our formal, well-written proofs, we will not want to use these symbols. Now let's look at a more specific example that take all of these guidelines into consideration. This theorem states, let x be a real number and let a equal x minus 5. Let b equal x plus 3, and we want to prove that a times b plus a is equal to x squared minus x minus 20. Of course, we said that the first step was always to explore the problem a little bit, and you might want to try a few examples here. For example, if we let x equal 1, then, of course, we see that the theorem is true in this case. If you tried a few more examples, you would also see that those would come out true as well, giving us pretty strong evidence that this is a true theorem. But now we want to actually prove this thing. Perhaps the easiest approach to take is simply to write down a times b plus a and substitute in for those values the x minus 5 for a and the x plus 3 for b and do some simple algebra for that. And we see at the end that we have exactly what it was that we wanted to have, x squared minus x minus 20. And so this completes the scratch work of our proof, and now we want to write this down formally. Applying our formal writing techniques to this, we, as always, want to begin with a formal statement of what we want to prove. Once we are ready to begin the proof, we start it with the word proof in italics or in boldface, and then we follow that with an introductory sentence. The only assumptions are that x is a real number, and we have formulas for both a and b. Now that we've given an introduction, we want to begin the actual mathematical content of our proof. If we look back to what we actually did in the previous step, we know that we only used algebra each step of the way, and so we simply say that. Using algebra, we can show that a times b plus a is equal to all of these things that we have written here. Notice how we have well-aligned equations here. All of our equal signs are lined up down the middle of this work that we have shown. And this is the main content of the proof that actually proves the statement that we wanted to prove. And so now we are ready for a conclusionary sentence. So we have discussed all of these writing guidelines and writing techniques that you're going to need to use. But remember that the proof belongs to you, and you should write it using the words and using the language that you would naturally use. Don't try to make it someone else's proof. Make it your own. The main thing is to always keep in mind that you are trying to communicate to the reader, and you want to write in a way that you understand, you want to write in a way that they understand, and you want to write in a way that you are communicating together.